Hi everyone, and welcome back to the channel. So in this video I am going to continue with the shaders material topic and show you how you can use custom shaders to map a texture on a geometry. Now I know we can do that easily using MeshBasicMaterial, as I have explained it in another video of mine, and I put a link to that up here. But with custom shaders we have more options to basically manipulate the either position or color of the geometry vertices on which our texture is mapped. So for example, here I have these like image textures that are on top of like basically a plane geometry, and you can see with this hover effect I can like have this hover effect, and that can only be possible through custom shader coding. Or like when I scroll, pay attention to the bottom of the screen, you can see like there is also a kind of like a effect down there, so that's also something which is possible using custom shaders. Or if you look at my portfolio website, this like an about page, you can see this earth. Basically I have this texture on my sphere geometry. That can be done easily with mesh basic geometry, but I wouldn't be able to do the rest of this, like these lines and like the atmosphere here. So in order to be able to do all that, I need to have a shader material, and I need to also code my texture basically inside that GLSL Vertex and fragment shader program. And so we're gonna try and to do that today. Before we get started, please make sure to hit the subscribe button below if you haven't already done that, and turn the notification bell on so that you're the first to know if I publish new videos. I will be doing a lot more videos, and so I want everyone to be aware of that. Alrighty, let's get started. As always, if you want to code along, I have the starter code of this project under this GitHub repo. This is basically the final code from previous video, which was part 1 of the shader material tutorials that I'm making. So go there, make sure to select the part 1 final, and then here from the code button here, download the zip file. I'll put a link to this repo in the description of this video. Once you download and unzip the folder, you can open it in your IDE of choice. I have VS Code here. Once you do that, first thing you need to do is npm install to make sure all the packages are installed and your node module folder is created. I've already done that, and then after that we're gonna do npm start to start our dev server. If you don't know what the hell is happening here, make sure to go check out my previous videos, and you'll find out what all these files and folders are, what we just did here, npm start, all those things. So go check those videos out and then come back. If we go and look at localhost 3000, this is where we left last video inside our ThreeJS endpoint here. We have this sphere geometry that we added some custom shaders, and we have basically a mix of colors on it. First thing we're gonna do, I'm actually going to, if we open the index.js under ThreeJS folder under canvas. That's where we have all the ThreeJS related code for this page. If you don't know again what these files and folders are, I'll put a link to basically a playlist for ThreeJS that I've created, and you can start from the beginning. So yeah, if you open this index.js file, that's where we are creating our scene, our render, camera, everything there. And in one of the previous videos, we also created a plane geometry with like a texture on it. I have commented that out, but now I'm gonna basically bring that back in. Now we're gonna be able to see this plane also in our scene, and I am going to actually get rid of the axis helpers there, and let me actually save it. And yeah, let's get rid of that axis helper there. One thing I want to show you is so we have this like our plane geometry up here, and our camera is down here, and we have orbit control. We can like zoom in and out and like drag, but for this video I'm gonna show you how you can actually like put your camera up here and kind of look directly at this plane here. This is a very important thing, because later on in some other videos, when I start talking about scroll based animations, that's basically what's happening in here also in my portfolio. And what I'm doing here, I'm playing with the position of this my object, and also like my camera position. So it's important to make sure that you can place your camera where you want to as easy as possible, and that's what we're gonna do here. So my plane position is at location 222, so it makes sense for me to put my camera a little bit further towards the outside of the screen, and that's the z-axis. So I'm gonna put it in at 224, and we're doing that up here. The camera position is at 224, and let's see if we can achieve what we were looking for. Right now there is a problem that the camera is actually looking at the 000, which is down here, and so that's the problem here. We are not directly looking at my this plane here. So to fix that, we can get rid of this camera look at 000. That seems to be should be working, but if we look back again, we're gonna see that we still have the same situation. And the problem, well, not the problem, the thing here is that we have orbit control, and with orbit control we're always gonna be looking at the center, because then we have the options to move around, and the camera is always going to be looking at the center of the screen or our scene. And so to fix that, we are actually going to get rid of this orbit control and all the related code, and don't forget the controls update inside our update function, because the controls is not defined anymore, and you may get an error if you forget to get rid of that. So this one, this control update, the control these two lines here, and also this one import, we don't need that anymore. So if I save now, you will see that I am now directly looking at my my plane here. Obviously I can like drag or like zoom in and out because orbit control is not there, but that's what we were trying to achieve. And the sphere is still back there, and that's okay. we don't really care about that for this video. Like I said, we want to focus on mapping this texture on our plane using custom shaders instead of this mesh basic material that we have right here. So there are a few things that we need to pay attention to. So this mesh basic material under the hood is actually using a custom shader. It's like it has its own vertex shader and fragment shader code and all that, but this is just made easy for us by like Mr. Doob and other ThreeJS contributors, that everything behind the scene is being taken care of, and all we need to do is to just like define this mesh basic material and map our texture on our geometry. So just keep in mind that behind the scene is what's happening is what we are about to do. Actually, some of it, not all of it, obviously is still with custom shaders. Some of the stuff is still behind the scene, but we will be digging more into what actually is happening. And what actually is happening is that we have this texture, and with mapping the texture on the plane, what's happening is that the color value of the texture for like the given coordinates in the scene is mapped on the plane that's behind it, on the vertices on the plane behind it, and each value of the texture is mapped on the corresponding vertex with the same coordinates on the plane. So that's a very important thing to remember, and I have actually added this here, and we're gonna get back to this. The key point here is that the color value of the texture is being mapped. So if we want to do this custom shader coding, we need to manipulate the color of our geometry to like map the texture color at given coordinate on that same coordinate on the plane. So that from the previous video, we've learned that the color part is happening in fragment shader as opposed to the positioning of the vertices, which was happening in our vertex shader. So for this texture, to add that, to map that on our geometry, we need to do some coding mostly in our fragment shader. So first thing I'm gonna do is to convert this mesh basic material to just a shader material. I'm gonna keep the double side here, but it will obviously get rid of map because that's not how it works with custom shader. We're gonna define our vertex shader and fragment shader for this shader material. Keep in mind for our sphere geometry back there, we also have a vertex and fragment shader file, but these two, the new one for the plane, are gonna be texture vertex and texture fragment, and we are going to create new files for them under our shaders. I've already created them. We have texture fragment and texture vertex. As I said, since we are manipulating the color, that's the main thing, we are going to map the color of the texture on our, for each coordinate on the plane. We will be working on the fragment shader file, and that would be the texture fragment.glsl. So I have what I have right now is just like, if we look at the fragment file for our sphere here, and we discussed that in the previous video, I have just included this upper part. This is just some troubleshooting of GLSL code, and also I just have my void main function here, so nothing special. Now, two things that were very important in this sentence, in this explanation here, were first of all the color value of the texture, and then secondly we need to have the coordinates so that we can map the color on that coordinate. And to do that, obviously we need to somehow pass our texture, which is basically this JPEG image that we have, and we use texture loader to convert it to texture, pass that to our fragment GLSL file. And to do that, ThreeJS, if you look at the documentation, there are basically uniforms that you can use to pass data from your JavaScript file to your GLSL file, and you need to like give it a name, the variable, the data that you're passing, and then pass that using the value parameter for that object. So what we're gonna do is we're gonna define a uTexture uniforms. We're gonna do uniforms, as they say here, uniforms, and then we're gonna name it uTexture, U for uniforms and texture for texture, and the value is gonna be this texture one. So now we are passing this texture one to our texture fragment file. And to get that here, all we need to do is to basically declare a uniform and then the same name that we had here, which was uTexture. And that's how we can receive it in our GLSL file. But there is a problem here. And if you look at this troubleshooting of here, we're gonna get an error if we forget to declare the type of the variable. So it's very important that we declare the type of this uTexture variable. But what is the type? We don't know that right now. Thankfully, on that same page, if you scroll down, we have this uniform types, and here, if we have JavaScript file of 3.texture, we know that our GLSL type is going to be sampler2D. So simply just we will add sampler2D to this. Now we have also declared the type of our uTexture. And if you want to know what sampler is, you can Google it, but there is also this like explanation under the OpenGL website. I'll put a link to this also. You can take a look at it. But what we need to know at this point is that that's the type of the texture variable, and it is basically a two-dimensional kind of like coloring or coordinate for our texture that we will be mapping on the actual coordinates, on the same coordinate on our plane geometry that we have. So that's the first part. We wanted to have our texture somehow in our fragment shader file, since we wanted to access the color there. And then the next thing is that we need to have access to coordinates of our scene. And this coordinate, if I open my Vertex file, if you remember from the previous video, I have included this like code that we had from there for this texture vertex, and if you open the other vertex GLSL, which was for our sphere geometry from the previous video. We had all these like different things that I explained previously. Instead of all that, I also told you that you can just like do this line, which combines all these other lines, and that's what I'm having here in texture Vertex GLSL, exactly that same line, and the key is that this position variable, which is a vec3, so xyz coordinate, is actually kind of what we need here to get access to the coordinates in our scene and then do the mapping of the texture on the coordinates. But the problem is that that's not exactly what we want. That's a vec3, and what we need here at the end of the day for our texture is a coordinate that has just two it's a 2D coordinate, and luckily again ThreeJS provides us with UV coordinates, which are basically the two-dimensional coordinates for our scene. So imagine like this plane geometry is obviously a 2D object, so we'll have like let's say x and y for that, and then we'll use the same x and y to map the texture on the plane. But even if we have like a sphere geometry, which is a 3D object, we can actually get the UV coordinates of that through a process called like UV unwrapping or UV mapping. There is an article here. I'll also post the link to this in the description box. It explains what like UV mapping is and how this works. Basically, it converts the 3D XYZ coordinates to like a 2D just XY coordinate, and that's all we need here. We need a UV coordinate, and again thankfully we can have access to that UV coordinate in our Vertex GLSL file. Even though we need it in fragment, we have access to that in Vertex, and from the previous tutorial we know that we can pass variables from Vertex to our fragment file through varying type, and so we can define a varying. It's gonna vector to, we call it VUV. This first V is for varying, and then UV, and then we can pass the value of UV, which is given. This is like a position. We have access to that UV coordinate in our GLSL file without having to like declare a variable or anything, and we're just passing that to VUV. We can't use this UV directly in fragments, so we have to pass it to VUV, and then through this varying type we will send it to our fragment texture. And if I can receive that again by defining exactly the same thing, VUV, it's a vec2 and it's varying type, and the names obviously should be exactly the same. Okay, so now if I save all these files, let's see, I have this, I saved this guy, and of course I have saved my index.js, which I've added these files. Let's see if we see actually anything here. Okay, so we do see that that whole plane is actually dark now. It seems like this shader material here, we know that we are like adding that texture, but in our fragment shader, which takes care of the coloring and everything, we don't have the GL fragment frag color that we'll assign the colors as I've explained in my previous video. Again, go check that out if you don't know what I'm talking about. So since we don't have that in our fragment for this plane, that's what we see. It's just a dark scene, and obviously there's a warning here that since we haven't used this VUV yet. Now we have the color value of the texture using this sampler 2D, and we also have the coordinates. Now how can we combine these two to get our final color, which again is going to be a vec4? And the coloring in here in this file means like the individual color value of like all the coordinates for our texture. And to do that, if we go to the book of shaders, we will see there is this function, or this function that we can use. And if we look at the description, it actually is exactly what we're trying to achieve. So since I already knew this, I kind of like backtracked, and then now we see that the color value of texture for the given coordinate, this texture 2D is going to return that. And all we need to do is pass our sampler 2D, which is our texture, like the image texture that we sent from the JavaScript file, and also our UV coordinates, which is also a v2, a vector2 type variable. So what we're gonna do, we're gonna define a vec4, we name it color, and our texture 2D is going to be receiving our U texture and VUV, and then we're gonna assign that to our GL frag color, which is what we need. And hopefully that should take care of mapping the texture on our plane geometry. And yes, you can see that here. So seems like everything is working fine, and we have been able to use custom shader coding instead of these like 3 lines. We have actually a shader material, texture fragment, and texture vertex. We didn't do much in this vertex. We just passed the UV coordinates to fragment and then took care of the texture mapping here, because we were mapping the colors on each coordinate. So that's about it. Now we've done this, but as I mentioned in the introduction part of this video, we do that because we need to add more stuff to it. We want to do things that we can't do with MeshBasicMaterial, and so let's add some stuff to it. We've already learned how we can pass data from our JavaScript file to our GLSL file, so we're gonna work more on that. First thing we're gonna do is actually we're gonna work on changing the alpha or opacity of this image texture, and again, since that's part of the fragment shader, will be mainly doing our work here. But we need to pass a variable, a data point from our JavaScript file to our fragment shader. And to do that, first thing I'm gonna do is actually we did have some kind of like animation on mouse down, basically on click, with our plane geometry previously, and this has been disabled here but like in the original file where original video tutorial where I explained to you all these ThreeJS concepts, it's there. Go check that out. I put a link to that video up here, and then you'll see how this is working. But here, let's bring this animation back, and you can see that right now if I click on this plane geometry here, it's gonna like zoom everything down, and when I let go, it's gonna like double the size of it and scale it twice, and that's what's happening here. A mouse down on a mouse up. Again, go check that other video where I explained this. But now we're gonna do another kind of manipulation where when we click on the image, and this time we just only want to affect the plane itself. Right now with this thing we are actually affecting the whole container of this canvas where all our geometry and the scene is. So to do that, I am going to define a new variable u alpha with a value of 1, and then I'm going to pass it to my fragment shader. And again, the way we receive it is just through defining a uniform. It's going to be a float u alpha, and don't worry about this one here. I know we're receiving a float here, but if you go back and check on that uniform explanation again, if you have a JavaScript type of number, it's fine. You can like it can be just a number, and you can define what type you want, either integer or float in your GLSL file, and obviously we need a float here. So that's it. And how do we change this on click? It's actually simple. First thing we need to do, I'll just get rid of that timeline that we had, gsap timeline. I define a new timeline, and that's gonna look at my plane material inside the uniforms, and then change the value of all alpha. So my target is going to be my the uniform u alpha of uniform in my plane material, and the parameter that I'm changing is the value. So this is how you define it. So if you look at this one up here, we were accessing our target, which was this class, and we were changing the scale of that class. Now we're doing the value, changing the value of this target. Our target is the u alpha, and that's how you get that. Now I've changed it. In order to have access to the plane material, I need to change this, make a little bit changes here. This needs to be this plane material, and obviously this guy here, we need to update it. And then I'm also gonna get rid of the on mouse up event code here. We're just gonna focus on clicking, and it's okay. We don't want to do anything when we let go. So if I save this one here, right now, let's see. Nothing should be happening because first of all, I haven't saved my fragment. So we have the click happening here, but we got rid of the existing animation there. We have our new animation to animate the value of u alpha, but we need to work with this u alpha in here. And if you remember from the previous video, or I can just explain again here, this vec4 color, it's actually an rgba value. So you'll have like red, green, blue, and alpha, which is your opacity. And all you need to do is actually to get the RGB from this texture 2D, and then apply u alpha here instead of the actual opacity, instead of A for RGBA. And you can do that easily by Getting the RGB from texture to the is easy. .rgb will give you the RGB, and then that's, by the way, be careful, that's gonna be a vec3 now because RGB has only 3 elements, and then you'll add the U alpha to get the final vec4. This is gonna have your RGB, and this is gonna be your A opacity alpha. And if I save this here and look at our endpoint 3JS here, I have to reload. It's the M1 chip of Apple, the new laptop. Anyway, so if I click on it right now, it's gonna fade out, but there's a problem. We again see that like it seems like it's still there, and if I click on it, you'll see that number is increasing and it's still there, and the opacity is kind of like now it's all dark. So to fix that, we actually need to add another parameter to our shader material, and that is transparent. We need to set transparency to true, and if I save it now, it is going, the U alpha, the opacity changes are gonna take into effect. And if I click now, it's all gone, so it disappeared. Now if I keep clicking, it's still there, and that makes sense, it's still there, but the opacity is 0. So to get if you want to completely like get rid of it, you will also probably need to scale down your object, and to do that you can just tag another gsap2 to the end of your timeline. This time you're like scaling the whole plane, your whole mesh here, scaling it down to 0, and I added this 0 part to make sure these two are happening at the same time. That's a gsap thing, so I've explained it in another video of mine, but that's how it works. If you want these to happen at the same time, you add this 0, or there is also other options that you can look online for that. So I'm gonna save this, and now let's see here. I have my plane texture, right? You saw that it kind of like shrank down, and also now it's gone. I keep clicking right now, and nothing, this number is not increasing. So that's one thing. You can obviously, your creativity and imagination is the limit, so I'm just telling you how you can do these things. You can like come up with ideas on your own. That was one thing about again, we manipulated the fragment shader, but I also want to explain another way that we can actually work on the vertex shader, and that is using some kind of like a variable that changes over time and kind of like move our plane around the scene, kind of, you know, since that's moving, that's related to position of the vertices, and vertex GLSL will be in charge of that. Something like for example, like I have in my portfolio, in my portfolio page, I have this object constantly like rotating. You see that happening. So that's the kind of thing that I will be showing you how to do. In one of my previous videos, I told you about the clock object that ThreeJS also offers. We're going to use that again. The 3 clock, it's an object for keeping track of time, and we are going to use that in our update well, before that, we're gonna get also the basically the elapsed time from this from this 3.clock object, and then pass that to our shader code. Again, we are using uniforms. We can use uniforms, and I should probably mention that uniforms are the type of data that don't change among the vertices. You might have data that change for different vertices that you need to use attribute. We'll talk about that in another video. But since these data, the data that we have passed to our shader files, they don't change among the vertices, we are okay using uniforms there. So again, uTime here is going to keep track of our time, and we'll be passing that to our shaders. And in our update function, which is happening frame by frame, we're gonna use the get elapsed time from the clock object of ThreeJS. This is basically gonna get the seconds passed since the clock started. And then similar to what we did with GSAP here, this time we don't want to do animation between the values. We just want to set the value of uTime in our uniforms to elapsed time. So this is gonna be like seconds, 1, 2, 3 seconds. So it's gonna keep increasing. And so we need to receive that variable here, uTime. We receive it here, and what we're gonna do actually, since we want to manipulate the position, we can't directly change the value of this variable position that is provided by default to us. We need to actually save the value of that into another variable. Don't forget to define the type, and then we will start manipulating this value, the new pos value, and then we'll replace this position with that. And again, don't forget to declare this vec3 here. Like VUV, we've already declared here. Position, it's by default known what it is, so we don't need to worry about them. But the new variables that we're defining, definitely make sure to declare their type. What we're gonna do, we're gonna use some trigonometry functions, specifically sine and cosine here. You can grab the x position using .x, y.y, and z.z. What we are doing here, since like our uTime is increasing all the time, if we don't use any of these trigonometry functions, it's just gonna keep increasing, and your your object is just gonna be moving outside the scene. But with sine and cosine, you're kind of like oscillating. If you see the sine and cosine function, it just goes from -1 to 1 and never goes beyond that. So that's why we want to use this. If I save this, well, we're gonna see the same thing because we are still using position here. We also need to change that to new position. And now if I save this, our uTime is constantly increasing, but the sine and cosine don't let it go above 1, and it's just gonna like oscillate between -1 and 1. And that here is what we see here. Our plane is basically like moving like in a circle kind of thing, and that's what's happening. Using these functions, we can get rid of like y and z transformation, just like move it along the x-axis so that we can see what's happening there. Again, what I have here, it's just like to show you how you can do things. Obviously this is just like a simple example. I don't know if you have some kind of like pendulum or something, maybe this is good for that, but you just use your imagination and creativity to come up with the ideas, and this is how you do it. If you want to like pass variables from your JavaScript to your shader files, that's how we do it. And then if we go back to this website here that I've created, there are some noise functions that you can use for creating this kind of like distortions. You can like Google noise functions for shader distortion, like vertex distortion, and you will see some code like in GitHub and other places. You can use, I'm like using one of those noise functions here to create this, and also the scroll effect in this website. All right, I think that's about it. We talked about different things that you can do with ShaderMaterial and how you can pass different data, and you can like do your vertex and fragment shader in order to map your textures on your plane. So I will have another video, at least one or two more video, because eventually I guess our goal is to do something like this with some hover effect, and then maybe we'll go even further and do the hold and this animation also, but that's I'll see what we can do there. Anyways, thanks a lot everyone for watching this video. If you enjoyed this video, if you found it helpful, please make sure to hit the like button below, and also don't forget to subscribe to the channel and turn the notification bell on. If you have any questions, please leave a comment and I'll make sure to get back to you as soon as possible. I will post the final code of this video also as probably part 2 final here, and put a link in the description of this video, plus a link to all the other stuff that we saw during this video, so that you have also access to them. And thanks everyone again, and I'll talk to you soon.